Welcome back everyone. Today we learn about redox reactions. The areas we will be focusing on are the definition of oxidation and reduction, oxidation state calculation, determining oxidizing or reducing agents in a redox reaction, and common oxidizing and reducing agents. Redox is an occurrence of oxidation and reduction. Oxidation occurs either when oxygen is added as seen in the formation of magnesium oxide from magnesium, or when hydrogen or electrons are removed as seen in the example of sodium losing an electron to form a cation, and oxidation results in the oxidation state increasing. Reduction occurs either when oxygen is removed as seen in copper being formed from copper oxide, or when hydrogen or electrons are added as seen when the chloride anion is formed from chlorine, and it results in oxidation state decreasing. In the calculation of oxidation states, keep in mind that the oxidation number of an element is always 0. The oxidation number of an ion is the same as the charge of the ion. The oxidation number of oxygen is -2 except in hydrogen peroxide where oxygen is -1. And lastly, the oxidation number of hydrogen is always +1 except in hydrides where H will be -1. Not only that, the sum of oxidation numbers of an ion is equal to the charge of the ion, and the sum of oxidation numbers of atoms in a compound is always equal to 0. In this example, identify the oxidation state of nitrogen in each of the following compounds and ions. For the first example, the oxidation number of nitrogen is -3 as hydrogen is +1. In N2, the oxidation state is 0 as it involves elements. In NO2, since the oxidation state of each oxygen atom is -2, N has an oxidation state of +4. In NO, similar to the explanation of NO2, the oxidation state of nitrogen will thus be +2. In the nitrate ion, doing the math as seen in the calculation, you will be able to solve that nitrogen is +5. Lastly, in nitrite, the oxidation state of nitrogen is +3 as solved in the calculation as well. In this example, identify the oxidation state of carbon in each of the following compounds and ions. For CO, since O has a charge of -2, C will be +2. For CO2, similarly, C will thus have an oxidation state of +4. For C, since it's an element, it will have an oxidation state of 0. For the carbonate ion, doing the math as seen, it will be solved that carbon will have an oxidation state of +4. For bicarbonate, similarly, carbon will have a charge of +4. In this final example, identify the oxidation state of sulfur in each of the compounds and ions. For S4, since it involves only sulfur atoms, S will have an oxidation state of 0. In SO2, since each oxygen atom has a charge of -2, S will have an oxidation state of +4. For sulfide and sulfate respectively, as seen in the calculations, it will be solved that their oxidation state will be +4 and +6 respectively. In conclusion, if one of the elements in the reactant has increased in oxidation state, the reactant would have been oxidized. While if one of the elements in the reactant has decreased in oxidation state, the reactant would have been reduced. An oxidizing agent oxidizes its reactant while it itself undergoes reduction. This can be seen in the examples below where either oxygen is removed, or hydrogen is added. A reducing agent reduces its reactant while it itself undergoes oxidation. This can be seen in the examples below where either oxygen is added or hydrogen or electrons are being removed. This equation below is an example of a redox reaction, and it shows copper oxide being reduced to copper, and therefore copper oxide is an oxidizing agent. On the other hand, ammonia has oxidized to nitrogen, and therefore ammonia is a reducing agent. An example of an oxidizing agent is acidified potassium manganate, where it changes from purple to colorless when it is reduced, and it forms the Mn2 plus ion, where the oxidation number of manganese decreased from +7 to +2. Another example of an oxidizing agent is acidified potassium dichromate, where it changes from orange to green when it is reduced, forming a Cr3 plus ion, and the oxidation number of chromium decreases from +6 to +3. An example of a reducing agent is potassium iodide, where it changes from colorless to brown, forming brown iodine from iodide, and the oxidation number of iodine increases from -1 to 0. Finally, another reducing agent is that of iron sulfate, where it changes from green to yellow after being oxidized, forming iron 3+, and the oxidation number of Fe will increase from +2 to +3. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye-bye.